Exponents. Exponents are an abbreviated way of writing how many times a number is multiplied by itself. So 5 to the 7th means 5 multiplied by 5 7 times. Or to be technical, 5 times 5 times 5 times 5 times 5 times 5 times 5. Which, as you know, is 78,125. In a term like 3x to the 8th, the 3, or the number in front of the variable, in this case x, is what we call the coefficient. The variable x is the base, and it's the number being raised to the exponent, and the 8th is simply the exponent. Let's get into operations with exponents. To add exponents, the base and the exponents must be the same. So x squared plus x squared is simply 2x squared. One of the most common mistakes you'll see is students seeing x squared plus x squared and think that it's x to the 4th. Remember, with addition, the value of the exponent never changes. It's the coefficient that changes. Subtraction works the same way. Take a look at this example. 5x cubed minus 2x cubed. Remember, the exponent and base don't change, only the coefficient does. So here, we simply have to subtract 5 minus 2 and we get 3x cubed. Now, multiplying and dividing exponents works differently. In this case, the exponent is the value that changes. When multiplying expressions with identical bases, you simply add the exponents. So a squared times a to the 5th equals a to the 7th. And when dividing expressions with identical bases, you would subtract the exponents. So for a to the 7th divided by a to the 3rd, you would get a to the 4th. Remember, in order for this to work, the bases have to be the same. If they're not, you wouldn't be able to combine the exponents. Let's quickly run through some other basic exponent rules. When an exponent is raised to another exponent, you multiply the exponents together. For example, 6 raised to the 3rd raised to the 3rd equates to 6 to the 9th, which is the small value of 10,077,696. A fraction raised to an exponent simplifies to both the numerator and denominator raised to the same exponent. For example, 5/7 squared equates to 5 squared over 7 squared, which is 25 over 49. Similarly, when a product of two or more numbers is raised to an exponent, we can distribute the exponent over the different factors. So xy to the a equals x to the a times y to the a. Note that this can be done with any number of factors. A number raised to a negative exponent equals 1 over that number raised to the same positive exponent. For example, 3 to the negative 3rd equals 1 over 3 to the 3rd, which is equal to 1 over 27. Any number raised to 0 is 1. Any number, whether it's 1, 500, 2,000, or 3 million. Any number raised to 1 is simply that number. For example, x raised to the 1st is x. Scientific notation is a method of expressing very large or very small numbers using exponents. 6.3 times 10 to the 6th simply means that you move the decimal point 6 tens places to the right, or add 5 zeros, as you can see in the illustration. Multiplying a number by a negative exponent means moving the decimal point to the left. So 6.3 times 10 to the negative 6 is 0.00000063. Let's try a practice problem. What is the largest integer n such that 2 to the n is a factor of 20 to the 8th? We can start this one by factoring 20 to the 8th. We'll cover factoring in a later lesson, so if you feel the need to brush up on it, you'll have the opportunity. Completely factoring 20 leaves us with 2 times 2 times 5 to the 8th. Recall that when a product is raised to an exponent, we can rewrite the expression by distributing the exponent over each individual factor. In this case, we get 2 to the 8th times 2 to the 8th times 5 to the 8th. Finally, remember that when multiplying expressions with identical bases, we can simply add the exponents, while keeping the base number the same. This means that for 2 to the 8th times 2 to the 8th, we just add the 8ths and keep the base of 2. Doing so leaves us with 2 to the 16th times 5 to the 8th. The expression of 2 to the 16th represents all the factors of 20 to the 8th of the form 2 to the n. Therefore, 16 is the largest such number, and is our answer.